for those of you in School of Science or those of you who are planning to take Calc 12 next semester, this example is probably the ugliest. However, you will see this again in the near future. So this is essentially an introduction to how we take limits and derivatives and slope functions and all that stuff, which all of that information you're going to get to know one day. But for now, let's just practice doing a composition. So we want to compute this function that I've highlighted in yellow, where h is not 0, for the function 2x squared plus 3. So this is f. You will notice that in this function here, or in this fraction here, in the numerator, we are going to have an x plus h as the input, and then just regular f in the second term. So we're going to be doing this very carefully. We're going to have the function evaluated at x plus h. So what is the function? 2x squared plus 3. But instead of just x, I'm going to write x plus h minus the regular f of x, 2x squared, 2x squared plus 3. So that is our numerator, and our denominator is just h. Okay, so anytime we see a function with something inside of it instead of just regular old x, we are leaving a space in the function where x is and replacing it by whatever we've been told to chuck in it. Okay, so now in order to solve this or simplify this, we're going to need to expand the numerator. It's going to get ugly, but it'll end up cute. Okay, we just got to give it some time to transform here. So x plus h squared, that's going to be x plus 2xh plus h squared plus 3 minus 2x squared plus 3. Nope, not plus 3. This should be a minus 3 because I am distributing this negative. So I've expanded these brackets and I've distributed that negative, and I still have an h in the denominator. Then I continue expanding. 2x plus 2xh plus h squared plus 3 minus 2x squared minus 3 all over h. Now I have to collect like terms. I have a positive 3 here and a minus 3 here, so they cancel. They go away because 3 minus 3 is 0. Then I'm looking for some other common terms. Can I put anything else together? Ooh, I've just caught a mistake I made. When I expanded this, right, this is a perfect square, x plus h all squared. This should have had a square on it, so this should have a square on it. X squared plus 2xh plus h squared. Yes, that's right. And spotting another mistake here, when we distribute the 2 has to go to all terms. So this coefficient is a 4. And I need to make a little bit of space here. This should have a coefficient of 2. I think I've caught all of them. All right, continue collecting like terms. I have a positive 2x squared here and a negative 2x squared there. That goes away. And whatever's left there, I cannot cancel or combine. So let's say we have a 2h squared plus 4xh all over h. Now, what else can I do here? I can factor the top a little bit. Let's do a 2h bracket h plus 4x all over h. Ooh, check this out. I have an h on top and an h on the bottom. So this is going to simplify to 2h plus 4h. x. And that's it. So started off really ugly, made a couple mistakes along the way. However, we caught them, we fixed them, combined them, simplified them, and this ugly beast came down to just two very simple terms. We are going to do more like this in class as well, and I'm sure you have lots more examples in your homework as well as Delta Math. So this is a skill that I'm going to ask you to practice quite well. We will continue using it going forward. Okay, so that is the last example for composition. The next thing we're going to do is decomposition, so essentially going backwards. When decomposing a composite function, we ask ourselves what function in the composition is on the inside, so the input value, and what function is on the outside. So here's an example. Given h is this, find the two functions f and g such that f of g of x equals h of x. So essentially, what is the inside function? What is the outside function? If I zoom in here, it's a little bit blurry, but that's all right. You can see there's two things going on. There's some stuff under the radical, and there is the radical itself. The radical is on the outside of the inside thing. So the simplest way I can do it is explain it this way. F of x, the outside, let's call it square root of x, and the inside, g of x, is going to be x minus 2. So that if I have f of g of x, it would mean I have a square root, and in it, I'm going to put the function x minus 2, which is g, which matches h of x. So I've done that correctly. In some cases, there will be multiple ways that you can look at it. Just do the way that makes sense for you. What is on the inside and what is on the outside? In example 9, given h is a cube root of x plus 5, find two functions, f and g. So essentially, we're asked to do the same thing. And here I'm going to do the same. The thing that's covering a lot of the stuff, I'm going to call f. F is the cube root of x. And the stuff that the root is covering, I'm going to call the function g, x plus 5. Such that if I did f of g of x, I would take the cube root, make it nice and big, and put the function of g inside of it. That matches what I had originally, so this is h of x. Again, done. Not too bad. Given